Good Thursday morning, everybody, and what another weird week we had. We were on school, off school, now we're back in school. We had videos, but hey, we made it to another end of the week. Without getting ahead of ourselves, let's go ahead and get started here with our lesson. What we usually do is we start off with our reading, and our reading this week is the Record Breaker. You see this dude here, got a hula hoop around him. I'm assuming this is about a record-breaking hula hoop performance, or maybe multiple record-breaking. Obviously, the first thing we also do here is we look at our table of contents. We have the Wacky World Records. We have Sharita and his mini records, Sharita's first records, planning and lots of practice, physical fitness and concentration, not always the best, and why he does it. So, Wacky World Records. Wacky World Records. Here, oh, those snakes, dude. What is the record for sharing a bathtub with the most rattlesnakes? Do you know who set the record for that? Most wooden toilet seat lids with a head in 1 minute, breaking the most wooden toilet seats heads in 1 minute. It's a weird record. What is the farthest distance someone has ever pulled a bus attached to his ears? How about the record for having the most snails in your face for 10 seconds? You really don't know. Where would you look to find the answer? Most people like you would probably look in the Guinness World Record book or Google it. Jack Bibby tried to set a world record for the number of rattlesnakes he could sit in a bathtub with. I'm guessing this was his one and only attempt because he got bit? Nah, I'm joking. Asherita and his mini records. Each year, over 50,000 people from all over the world try to set a Guinness World Records. Many people hold a single Guinness World Record. Few people hold several records. One man named Asherita Furman holds the Guinness World Record for holding the most Guinness World Records. Since 1979, Asherita has set more than 300 Guinness World Records. He says he's been setting his records isn't about beating others, it's about challenging himself. Asherita was very interested in the Guinness World Records when he was a young boy. As a kid, I had a huge fascination with exotic places and people listed in the Guinness World Records. But being a non-athlete, I never imagined getting a world record myself. So who can set a world record? Many world records are held by great athletes or people who are very good at certain sports. One of the best things about Guinness World Records, though, is that you don't have to be good at sports to set one. Think about the person who set a record wearing the most t-shirts at one time, 224. Or the person who made the fastest bologna sandwich using only his feet, 1 minute and 57 seconds. The people who set these records didn't have to be good athletes. They just had to work very hard at doing one special thing, no matter how crazy. Here's Sharita running a mile while hula hooping. Okay, well, that explains that cover photo. Asherita's first record. The first record that Asherita broke was for jumping jacks. He says he began jumping jacks because he knew how to do them. When Asherita began to train, someone held the record for doing 20,000 jumping jacks. Asherita could only do 50 of them. However, with lots of practice and hard work, he set a new record of 27,000 jumping jacks. Asherita was excited to see his jumping jack record printed in the Guinness World Record books. Next to the record in the book was a world record for somersaults. Asherita decided to go for that record too. He broke the somersaulting more than 12 miles. Oh, I would be sick. There's a picture of him. He's wearing a helmet. Asherita practiced somersaulting in the middle of the night so his neighbors wouldn't think he was crazy. Ways to prove you set a record. Number 1, ask official Guinness World Records to send a judge to watch your trick. They can't always do that, though, because there are too many people to set records every year. Send a video and photographs of what you did to the Guinness World Records. At least 2 people need to see and sign a paper that says that you have done it. Wow. Planning and lots of practice. Sharita enjoyed setting his first 2 world records, so he decided to keep going. Now he tries to set a record every 2 weeks. Some of the things Asherita tried required a lot of work. For example, he practiced for months that he could set a record for balancing 81 drinking glasses on his chin. The other things that Asherita tried were not planned at all. Once when he was traveling by train in Japan, he looked out the window and saw Mount Fuji, Japan's highest mountain. Asherita made a quick decision to climb on a pogo stick. He arranged to have his favorite pogo sticks flown in from New York. Within a few days, he set a record for bouncing 11.5 miles up and down the mountain. Dangerous world record. Sometimes world record is retired. That means the Guinness World Record no longer accepts applications from people trying to break it. One reason is records retired because the activity is too dangerous. Asherito was on vacation in Peru when he broke his own record for jumping on a pogo stick underwater. There were some flesh-eating fish in the Amazon River where he did it. Asherito was not harmed, but the Guinness World Records decided that the act was too dangerous. They retired the record soon after that. In Thailand, a platform was attached to the back of an elephant, so Ashrita could set a Guinness World Record for doing the most leg exercises on an elephant's back in 1 minute. Ooh, that is strange. A lot of weird records. Physical fitness and concentration. Some Asherita's world records require him to be really good in physical shape. For example, Asherita set new records for sack racing. He did it while he was racing against a yak, an animal little like a cow. With a cloth bag over his legs, Asherita jumped for 1 mile. His record was 16 minutes and 41 seconds. Other records required intense focus for a long time. Asherita needed to concentrate very intensely when he set a new record by clapping for more than 50 hours. That's more than 2 days of clapping. Some records require both fitness and concentration. Asherita needed both when he broke the record for bouncing on a pogo stick for a mile while juggling. His record for that was 23 minutes and 28 seconds. With a cloth bag over his legs, Asherita raced against a yak in Mongolia in Asia. This guy is just crazy. Asherita's records around the world. In the United States, ran a mile in 7 minutes and 8 seconds while balancing an egg on a spoon. That seems doable. Mexico completed 434 hopscotch games in 24 hours. No, thank you. England walked a distance of 32.81 feet with the heaviest shoes, 323 pounds. No, thank you. China bounced the fastest mile in 15 seconds, 15 minutes and 3 seconds. Australia hula hooped a mile in 15 minutes and 25 seconds. Maybe possible, maybe not. Antarctica bounced a mile on a pogo stick in 17 minutes and 45 seconds. Too cold. Not always the best. Asherita doesn't always succeed in setting records every time he tries. Do you remember the time that he clapped for 50 hours? Well, he didn't beat the record the first time. He first tried clapping in place in New York City that was very noisy. He had to stop because the other people were watching him couldn't hear his clapping. The next time he tried, he clapped by a pond where there was much easier to hear his claps. Once when Asherita was juggling in the water, he had to stop because a shark knocked one of the balls out of his hands. Yeah, I'd quit too. Why he does it? Like many other kids, Asherita spent a lot of time looking at the Guinness Book of World Records when he was young. He says, I remember carrying it around and reading it under the covers at night. Like many other kids, he probably dreamed about seeing his name in that book someday. Now his dream has come true in a big way. Asherita juggling act in an aquarium in Malaysia. Maybe this is where the shark got him. Got him with the balls. It's not just about breaking someone else's records. Though, Asherita explains, scoring for a world record is a wonderful challenge, and the person you're challenging really isn't individual who holds the current record, it's yourself. So never give up. Asherita's motto is never give up. Well, I think these are those 323-pound shoes. I might be able to pick it up once. About those records. Are you wondering about the records that you read about in the beginning of this book? Here they are. Number of rattlesnakes in the bathtub, 87. Number of broken toilet seats lids, 46. The distance between the bus was pulled was 20 feet. The number of snails on the face was 48. He did what? Asherita's Furman feat range from the fun to the fearless. Here are a few more of his amazing records. Longest distance carrying a 9-pound brick, which he carried 85 miles. What? No, that's crazy. The fastest time skipping in a marathon, 26.2 miles, is 5 hours, 55 minutes. Oh my gosh. Next one, fastest time carrying a person for 1 mile, 50 minutes, 12 seconds. The longest time keeping a top spinning, 7 hours, 1 minute, and 14 seconds. The fastest time pushing an orange with his nose, 1 mile, 22 minutes and 41 seconds. So what do you guys think you could get the Guinness World Record in? What would be something you could do as a Guinness World Record? What was something that you could be interested in? I don't know what I would do. I mean, maybe some of his records. I might have to look up a Guinness World Record, some easy ones. That'd be kind of cool. Think about what is something that you guys could do. Yeah, think about that. All right, so we've done our reading. Now I want to do something kind of new, I guess. It's called Educane. Educane. It's kind of a new site that I wanted to try out. And here it is, Educane. What I wanted to do, if I can remember correctly, is do what makes you happy. It's kind of a take on our friend Sharita. He was doing what made him happy. So here's a short video about doing what makes you happy.
Hi everyone, I'm Mr. Conley, and here's your mindset moment of the week. The story of who managed to trade. Here's the deal. Think of it this way, through one simple gesture of kindness. When I taught sixth graders, I would often hear them saying some variation of the following. I don't know what I want to be when I grow up, but I just know I want to make a lot of money. Let's pump the brakes right there and let Steve Jobs set the stage for this episode.
For the past 33 years, I've looked in the mirror every morning and asked myself, if today were the last day of my life, would I want to do what I'm about to do today? And whenever the answer has been no for too many days in a row, I know I need to change something.
Now, before I became an educator, I worked in the business sector by day and trained youth soccer teams in the evenings. I quickly realized I was looking forward to the evenings, helping out the kids, and not so much my day job. Here's the point. Nothing is worth more than your happiness. So don't think about what you want to be when you grow up or how much money you'd like to make. Just consider how you like spending your time, because that's where your true passions lie, and most often your greatest levels of happiness. So it's simple. Do more of what makes you happy. Here's my challenge for you this week. Think about how you like spending your time and consider what skills you're actually sharpening for your future life success. Think about it. I'll see you later.
That was a pretty good one. Obviously, I enjoy teaching kids or being around students and helping kids. So that's why I became a teacher. So think about what makes you happy. I think that Mr. Conley does a really good job there explaining that. And obviously, our friend here, Mr. Sharita Furman, does a good job of doing things that make him happy. Okay, so then that brings us to sentence editing quiz. Ooh, sounds like fun. This will be in your reading, so we'll open up Canvas, and I'll open up a new Canvas page for each one of them, so at the end I can kind of go back and recap them. There is virtual reading, and go to modules, all the way down to the 11th. Ooh, it's slowing down. Computer's slowing down. There we go. Sentence editing. Alrighty, so sentence editing. Connect the iPads. Strong sentences. How can you make your sentence more powerful? There are many ways to look back in your essay to improve what you've written. One way to make your sentences stronger is to add specific details. Another way is to combine sentences so readers see how your ideas are related. We'll watch this video to see how to do that. I'm like mouse all over the place, sliding around. Sorry.
Now, let's take a closer look at some sentences that might be in a first draft of a paper about knights and revise them to make them better. The main idea of the story might be written like this in a first draft. A boy had to learn to become a knight. That is true. But it does not tell what the boy had to learn. One way to revise that sentence is to make it more specific. A boy had to learn many skills before he could become a knight. More details give the reader more information. You can elaborate on the main idea with supporting details. He learned to fight, to ride, to handle weapons, and to wear a suit of armor. Now let's revise this sentence. Page, a young boy. You probably recognize that this is not a complete thought. you need to define your subject and add a verb. A page was a young boy who trained to become a knight. Another way to revise your writing is to find more descriptive words that make your sentences more interesting. Let's make this sentence more exciting. A squire learned to get onto his horse wearing armor. Get is not a very exciting verb, so we could replace it with leap. We could also describe the armor as heavy or clanky or both. A squire learned to leap onto his horse wearing heavy, clanking armor. What would you fix about these sentences? A squire learned to handle weapons, then he practiced fighting. Then he fought in tournaments. Combining sentences in different ways makes writing more interesting. Like this. As he learned to handle weapons, a squire practiced fighting in tournaments. Revising your work is important for any kind of writing. Adding information and details, varying your language, and thinking about your work as a whole will help you become a better writer. Draft a paragraph about becoming a knight. Then revise what you have written.
Alrighty. So, let me connect again. So after reading this paragraph about actors learning to play the roles of knights, use what you've learned in the video to look for places to add or combine sentences. The actors had to learn new skills to play knights on stage. It took them 3 weeks to figure out how to make a fight on stage look real. 3, the swords they used were fake. 4, the actors had to make them look as heavy as real swords. Which sentence needs to be expanded to add more detail? Sentence 1, the actors had to learn new skills to fight and make knights. Or 2, it took 3 weeks to figure out how to make a fight on stage. I would go either 1 or 2. I selected 2 just because I knew it was going to be the wrong one, so that way you could see that this second sentence provides many details. So it does provide some new details in sentence number 2. So let's go to our next slide. Opinion essay, final draft assignment. Which of your sentences need help? Go back to your opinion essay one more time. We'll look for places where you can combine or expand sentences. If you typed your story in the Word doc, make the changes that in the file that make sentences that you change a different color so I can see it. Don't worry about that part. We won't make you guys do that part. But the part I will make you do, instead of doing that, I am going to have you do this, which is your sentence editing quiz. Alrighty, so our next assignment is going to be in science. Let me open up a new science tab. Like I said, I like to keep these all open so that way at the end I can quickly scroll through them and show you guys. What we're doing is on the 11th, which is conservation of mass. I want to make sure I'm right. Yes, conservation of mass. So laws of conservation of mass. Is it possible to create or destroy matter? No, it's not. The law of conservation of mass states that the matter cannot be created nor destroyed, but does change from one form to another. This can be observed during physical changes, such as changes in dissolving into form a solution. The mass of the substance experiencing a physical change does not vary. Matter does not disappear. The phenomenon is also observed during chemical reactions. When the atoms of the reactants rearrange to produce a new substance, also known as the product. Watch the video below to learn a little bit more about the principle of conservation.
When we think of the word conserve, we often think of the conservation of water or animal populations or rainforests. The word conserve means to protect from harm or loss. In the study of chemistry, conservation addresses the fact that matter doesn't just disappear, but does transform from one form to another. This is known as the law of conservation of mass. The water in this kettle is undergoing a change of state from liquid to gas as it vaporizes. Although it may appear that the matter is disappearing as it leaves the container, it still exists because it is merely escaping into the atmosphere. This can be observed directly when matter undergoes changes in a closed system. A closed system is one where matter cannot escape. The ice in this beaker will melt quickly because of the heat added. How can we alter this experiment so that it takes place in a closed system? By adding a cover to this system, it is now closed so that matter cannot transfer in or out. All of the water molecules inside the beaker will remain inside regardless of the state of matter. You change matter in closed systems every day. Adding a spoonful of sugar to a cup of coffee will make a solution. Solutions are made when a substance is dissolved in another. Sweetened coffee is a solution. To look at how the law of conservation of mass applies here, we must first find the masses of the coffee and the sugar separately before dissolving the sugar. The mass of the coffee is 320 grams. The mass of the sugar cubes is 7 grams. Now let's dissolve the sugar in the coffee. What do you think the total mass will be? When we use the balance to find the mass of the coffee and sugar solution, we find that it is 327 grams. When we look at the mass of the coffee and sugar solution is exactly the sum of the mass of the coffee and the mass of the sugar. No mass was gained or lost. That's conservation. Phase changes and dissolving are both examples of physical changes. As seen in our examples, mass is conserved during physical changes. But what about chemical changes? When a chemical change occurs, atoms rearrange to form new substances. If you have ever combined vinegar with baking soda, you know that a chemical reaction occurs. The atoms that make up the substances rearrange when they are introduced to each other, producing new substances. One of the new substances is carbon dioxide gas. When vinegar and baking soda are combined in a closed system, as seen here, none of the atoms can escape. Because of this, the mass is conserved. Whether atoms are separate or connected with chemical bonds, their combined mass is always the same. These hydrogen and oxygen atoms can experience a chemical change to form water. The substances before a chemical reaction has occurred are called reactants. The new substances formed by a chemical reaction are called products. The hydrogen and oxygen react to form H2O or water. Water is the product of this chemical reaction. Chemical and physical changes of matter are happening around you and even inside you every day. The atoms involved in these changes always exist, connecting and disconnecting from other atoms, or simply taking in energy to morph into a different state of matter.
So where does your body begin to break down food chemically when you eat it? In your mouth. There are chemicals in our mouth, enzymes in our mouth that start the chemical reaction with your mouth and start breaking down in your mouth chemically. Obviously, your teeth break it down physically, but your mouth has enzymes that break it down chemically. So what is conservation of mass? In the properties of matter in this lesson, you will learn that the definition of matter is anything that has weight and takes up space. You will also have learned that matter can have 3 states: a solid, liquid, and gas. Think about water, ice, and steam. Additionally, you learn that matter changes from one state to another through heat energy, and that the matter goes through either a physical or a chemical change. Take a moment to reflect on all that you have learned. That's sort of a lot of information. In this lesson, you will use everything you've learned while studying the properties of matter to gain understanding. Conservation of mass is a law in science that states that mass can never be created nor destroyed, only changed. This means that the amount of mass is something that has at the beginning of a phase change or chemical reaction will remain the same after it has gone through the change. To conserve something means to save it. For example, conservation of biology in the scientific field saving animals in habitats they call home. For the purpose of this lesson, the mass has the same meaning as weight. So you could restate the definition of the matter by saying anything that has mass or takes up space. When you measure the weight of yourself on a scale, you're measuring your mass. The words mass and weight can be used interchangeably, so when you see the word mass, think weight, and vice versa. As you get older, we'll start to tease those out. They'll be a little bit different. Mass and weight will be a little bit different as you get older into more scientific classes. Say you weighed a whole apple on a digital scale and it weighed 75 grams. Then you place the apple into a blender and blend it until you had something that resembled applesauce. If you were to weigh the applesauce, it should weigh 75 grams. The original mass of the apple is the same as the final mass after the apple underwent a phase change from a solid to a liquid, or really sauce. The mass of the apple was conserved or saved and remained the same throughout the physical change of the apple. The apple is still an apple and only has a different form from the atoms that were arranged to make up the apple weren't permanently changed or rearranged to make something new. What happens to the conservation of mass when the atoms are mixed or rearranged as a result is a chemical reaction? In this lesson, you will build your own knowledge of properties of matter to learn about the conservation of mass. You'll also be conducting 3 short demonstrations of how the mass is conserved. So let's get started. If I can hit that button. There we go. Okay, so don't be discouraged about the scientific language used here to define the law of conservation of mass. You have already seen conservation of mass in action in your previous lessons, so you can review a few examples. In freshwater lesson, you learned about the water cycle, and we introduced the 3 states of water: solid, liquid, and gas. You know by now that water is the matter that takes up atoms, that has mass and weight, and takes up space. The water cycle demonstrates a conservation of mass when it comes to the water cycle through 3 main processes: evaporation, condensation, precipitation. You have demonstrated the water cycle and conservation of mass when you boiled a pot of water with its lid on. Now we will revisit this experiment and look through the eyes of the law of conservation. So here's the water cycle. Obviously, you have the collection, evaporation, condensation, precipitation. It could start here, it could start there, it could start anywhere. It continues on and on and on. Same thing here. You have the gas, the water to a liquid through a gas, and then back down to a liquid again as it cools down. When you fill the pot up with water and place a lid on it, you created what is called a closed system. Nothing was able to leave the pot, making it closed off to the outside world. The amount of water in one pot stayed the same throughout the entire process. In other words, the initial mass or weight of the water before you began to heat up the water had a specific weight. Then you added heat energy to the water by turning on the stove. As the water began to heat up, the atoms in the water gained more energy until they changed state from the liquid to a gas and evaporated into the airspace between the top of the water and the bottom of the lid. The same amount of water was still present in the pot. It just changed from the phase from a liquid to a gas. Once the water had boiled for some time, the gas particles hit the bottom of the lid, cooled, and began to condense. If you have turned off the water and heat and let the water cool down at room temperature, the water that had condensed on the bottom of the lid will begin to drip or precipitate, and the lid is left in the pot of water, and the water stays the same throughout the entire process as the water with the changes from a liquid to a gas, then back to a liquid. This is a direct example of conservation of mass, because the mass of the water was conserved and it stays the same. What would happen if you were to lift the lid of the water that was boiling around it and the hot water vapor escaped in the surrounding kitchen, or creating an open system? Is the mass of the water just lost or just transferred? Just like you learned in the water cycle, water can be changed from one state to another, but the amount of water, total water in the earth, remains the same. This is also true when you try to lift the lid of the boiling pot of water. The overall amount of water in the pot would decrease because the water atoms evaporated into the gas and moved in the surrounding area, but the water atoms themselves did not change. The water's initial mass would be different than the final mass after boiling, because some of the water would have evaporated. However, it's important to just remember that the water can only change phases. Okay, I'm going to have you guys, this is something that we will do together. This is what I call the chocolate chip experiment. This experiment we're going to look at what's going to happen to chocolate chips. But this is something that we'll do together. So you start thinking about some things that you guys might need. Obviously, you guys won't have a digital scale. And I know some of you guys have a microwave. You have a cup of chocolate chips, a spoon, a bowl, and obviously a help of an adult. You can always use just like a regular scale, like what you step on to weigh yourself. We won't do that today because that's something I want to do in person. It's something I want to introduce you to. But over the weekend, if you got some chocolate chips or a spoon or a bowl, even what was I going to say? Hershey Kisses, sorry. Things like that. Hershey Kisses is what I said. Things like that, or Valentine candy, we can make do with that. So this is what it kind of looks like. Looks tasty, and we'll talk about this when we do it together. So what is a solution? A solution is a mixture of two or more substances. I want to put out that you do not have to do that experiment. You do not have to do that experiment. That's something we'll do together. A solution is a mixture of two or more substances that can be mixed together. Solutions are often a liquid state when formed, but when they change phases into a solid or gas as well. An example of a solution that you're likely familiar with is sugar and water. When the sugar is added to the water sugar dissolves into the water. The atoms that make up the sugar separate and mix with the water atoms to form sugar water. However, the sugar atoms do not rearrange to become a new substance. In fact, if you were to leave the solution out until the water evaporated, only the sugar would be left. So here you have sugar plus water equals sugar water. This image below shows you kind of what's happening there. You have the solid, which is sugar, and then liquid, then it kind of dissolves or really rearranges itself with the solution there. That's a good picture. So that's the sugar, that's the water, and that's what it would look like chemically rearranged. This is something that we will doing together. Again, this will be the sugar and water and sugar and water. So in this one, we'll need again a scale, some Post-it notes, or maybe some tape, or just small pieces of paper, spoon, cup, sugar. Again, if you guys have these things, great. If you don't have them, don't worry about it. We can do this together on the following week. So I just want to make sure you guys saw this. So there's your sugar, there's your information, and this is what we're going to do another time. So chemical reactions occur, these are conservation of mass and chemical reactions. Chemical reactions occur when the atoms make up two separate substances and rearrange to form a new substance. For example, when you bake a cake, you add sugar, flour, eggs, butter, and other ingredients. Each of these four ingredients is a substance that you place your cake batter in the oven. The atoms from your ingredients are heated and rearranged to form a delicious baked cake. Remember, chemical changes are a result of chemical reactions and cannot be undone. Once you bake a cake, wouldn't you be able to convert the cake back to raw batter? Not butter. In every chemical reaction, there are two parts, reactants and products. A reactant is a substance or substances that are changed. In the examples above, the ingredients are used to make a cake that are reactants. The product and the result of the chemical reaction is the baked cake. Every chemical reaction has a reactant and products and results to a permanent chemical change. Cool photo. How are chemical reactions and the conservation of mass related? Just like the sugar and water experiment in the previous page, the combined mass of all reactants in a chemical reaction share the same mass and products. Again, this is the conservation of mass because when you begin, what is the same amount of mass should be the same in the final product. Using the cake example above, based on the conservation mass would mean that the mass of all the ingredients to make a cake should be the same amount as a baked cake. This isn't the same all the time because you know that liquid ingredients in the cake batter evaporate as the cake is baked, so some of the mass can be reduced as cake particles evaporate into the air. The cake particles that evaporate have simply changed phases, and they're not lost or destroyed. They simply have changed from a liquid to a gas, so their mass has been transferred to the surrounding areas. That looks tasty. Tasty, 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 tasty. All right, so then this takes you guys to your quiz, conservation of mass quiz. All right, let's go on to our next slide. Here is our next slide. You see there's our lesson from Tuesday. We're going to do the order of operations. So now we're switching gears. This is something that we did earlier in the year that we probably should have waited till now to do. So I think it makes more sense now to do than earlier in the year. So this one's called the order of operations. Some of you guys may have know this as PEMDAS. PEMDAS. Parentheses, exponents, multiplication, division, addition, and subtraction. Let's go ahead and investigate what in the world does that all mean. Introduction to operations. A lesson you're going to be working with different expressions and symbols that can be used. First, you need to make sure that you know what the four operations of math are. Do you remember? Think about it. Remember we talked about it? PEMDAS. So when you have practiced these operations for many years, you should know the basic facts pretty well. In this lesson, you will use adding, subtracting, multiplying, and dividing to evaluate numerical expressions. You may be wondering, what is a numerical expression? Well, it's a math sentence. Anything that has an operation symbols like plus, minus, in multiplication, divide. So here is your numbers and you have symbols. In this video, we're going to follow Mr. Brady describes why it's so important to follow the order of operations. All right.
Hello, my name is Mrs. Brady, and today we are going to be doing problems where we're understanding why the order of operation is important. Okay? So let's do these two problems. Let's do one where we do the order of operation, and let's do the other one just out of the blue, just like any way we feel like it. Okay? So let's see. 3 minus 2 plus 5 times 6. Well, I want to do 3 minus 2 first. So I'm going to do 3 minus 2. So I'll do 3 minus 2 equals 1 plus 5 times 6. Well, I can add 1 plus 5 really easy. So I'm going to do 1 plus 5 because, it's first. It's easy to do. I can get it really fast. I'll do the problem fast. So I'll get 6 times 6. That equals 36. All right, did the problem. But how do you know if that's right? Let's try it with the order of operation.
We do 3 minus 2 is 1 plus 5 times 6.
Well, the order of operation, you have to multiply first. Okay? So according to the order of operation, we have to multiply 5 times 6 first. That's 30. And then we add 1. And that's 31.
So you can see how that much changes the actual question. So that changes the answer a lot. And we're going to practice that here today. So let's go ahead and practice that now. Just a quick order of operations. We always do multiplication and division first, and then we do our adding and subtracting. So I think that is turning on. Let me write the problems down first, and then I'll show you my screen. So I'm doing 4 plus 6 plus 3, 7 minus 3 minus 2, 6 times 2 times 3, 8 divided by 2, divided by 2 again, 8 plus 7 plus 3. Those will be the ones that we do. So none of these really have any special tricks. Let's see if that camera works. There we go. So none of these have anything special about them, right? These questions here, right? You simply do 4 plus 6 is 10, and then plus 3 is 13. 7 minus 3 is 4, minus 2 is 2. 6 times 2 is 12. 12 times 3 is 36, I believe. 8 divided by 2 is 4, and then 4 divided by 2 is 2. 8 plus 7 is 15, plus 3 is 18. There's nothing really special about that because they're all the same. They're addition and subtraction, subtraction. So nothing special about those. They will get more special as we go on here. So what is the order of operation? And yes, you may use your calculator. So order of operations, let's listen to Miss Karen here, our teacher here, and she will describe exactly what is an order of operation.
Now, speaking of interesting and educational, the next activity we're going to do, I'm going to have the students use their calculator. So can you each hold up your calculator for me? Okay, notice I've given them different kinds of calculators, at least different brands, okay? Now we're going to show you a mathematical expression right now. And what we want you to do is we want you to use your calculator and evaluate this expression. So you want to punch in 4 plus 2 times 10 divided by 5. Okay. And Leslie, what'd you get?
I got 12 for my answer.
Leslie got 12. Okay. Sam, what did you get?
I got 8.
You got 8. Okay, now you both press 4 plus 2 times 10 divided by 5?
Yes.
Okay, but you got 12 and you got 8.
Yes.
Do you think that maybe somebody's wrong? You think somebody's wrong? You got different answers?
Maybe.
Do you think somebody's calculator's broke?
No, I think maybe that this calculator might have a built-in chip that makes it do order of operations.
Oh, so you might have a different type of calculator?
Yeah.
Okay, you know what? You're right. Sam has a type of calculator that can automatically think and perform what's called the order of operations. And Leslie's, yours apparently can't think too much on its own, so it needs you to be thinking there, right?
So it does matter which type of calculator you get. So what they're referring to is a scientific calculator. So what do we do here? So let's just go ahead and just do some examples. I think it's the best way of just doing this is by doing some examples. Here are some of our examples. Let me write them down. Excuse me. 8 divided by 2 times 6. The next one is 9 minus 3 plus 7. I think those are our 2 ones, right? Yes, okay. So, here we go. So, what you need to do, in this case, is what we call PEMDAS, or please excuse my dear Aunt Sally, or Sarah, or whatever. Please excuse my dear Aunt, say Sarah because we have a Sarah in the class. Please excuse my dear Aunt Sarah. What this means is parentheses, exponents. We will we probably won't do too many of those, but we could. Multiply first, multiply, divide, addition, subtraction. So this is the order. So order of what it should happen. This should happen first, this should happen second, third, fourth, fifth, and sixth. So we should do everything in order first like that. So there's no, these first 2 problems, there's no P or E. There's no parentheses and exponents. Let's focus on the M and D. So we got to do the multiply and divide first before we, wait, do we, or in this case, yeah, okay, I want to make sure I wrote the problem right. So in this case, multiply and divide first. So we could, so it does say M before D, so we got to find the multiplying first. 2 times 6, I try to trick you there. So 2 times 6 is 12, and this one is 8, so you simply do 8, or 12 divided by 8. So 12, we're clear. I'm using the calculator. 12 divided by 8, you get 1.5. In this one, you have addition, subtraction, so you need to add first. 3 plus 7, and then you subtract it to get 3 plus 7. Well, in this case, 3 plus 7 is 10, and then 9 minus 10, you end up getting with a 1. Okay? And we'll do some more examples. I love doing those examples. Now they're going to be getting harder. Look how hard they're getting now. 4 plus 9 divided by 3 minus 6. These are the ones you're going to see more often. So let's look at these ones. I'm going to write these ones down. You guys probably can't hear because I don't have this thing on as well. So 4 plus 9. 4 plus 9 divided by 3 minus 6. 7 times 3 minus 5 plus 4. Okay, get you guys the camera back. Okay, so remember PEMDAS. Let's rewrite it down here so we see it. PEM. Oh, I forgot. PEM. Well, there's an M in PEM. DAS. Okay? So, there is no parentheses and exponents. We don't have to worry about those. So, we need to do multiplying first. Is there any multiplying in this one? No. Is there any division? Yes. It's 9 divided by 3. 9 divided by 3 is 3, so we keep that plus, we keep that 4, we keep that minus 6. So in here, we can just simply just work it from left to right. It'd be easier. 4 plus 3 is 7, minus 1. So the answer is simply just, well, minus 1 is 1, right? 4 plus 3 is 7. I'll write it out. Minus 6, and then that equals 1, okay? On the bottom down here, there's no exponents and no P and E, so we need to do multiply first. So, multiply. Oh, this is multiply. 7 times 3 is 21, minus 5, plus 4. For me, I know this is going to be easy. If I, well, let's do it like this because it's all in this order. 21 minus 5 plus 4 would equal 20. Okay? Oh, there that is. I'm zoomed in too far. Sorry about that. More examples. These are fun. Hard but fun. Okay, order of okay. Now, where are my examples? Okay. Yeet, 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 yeet. These are going to be hard ones. Okay. So Crystal brought 2 pounds. I need a new piece of paper. Crystal bought 2 pounds of candy as gifts. Oh, that's nice of her. 2 pounds of candy as gifts for 4 different people. So let's go ahead and, so he had 2 pounds, LBS, for 4 people, She also bought 3 pounds of almonds for 2 other people. Yes, I do. She bought 3 pounds of almonds for 2 other people. So 3 pounds again for 2 other people. How many pounds did she buy together? Okay, so how many pounds did she buy together? Well, that's pretty straightforward, right? So if she bought 2 pounds of chocolates for 4 people, that's 8 pounds. If she bought 3 pounds of almonds for 2 people, that's 6. I can do that math. How many did she get total? 8 plus 6, which is 6 plus 6, 14. She would have 14 LBS. Okay? 14 LBS. Because she had 2 pounds for 4 people, then 3 pounds for 2 people. And then on Friday, Jade sent 5 text messages to 3 people. So let's try that. 5 texts. 5 texts to 3 peeps. And 5 texts to 3 different people. On Saturday, she sent 7 text messages. 7 messages to 6 different people. 7 messages to 6 different people. So 7 texts to 6 peeps. Call people peeps now. How many more messages did she send on Saturday? Well, okay. So how many more messages did she send on Saturday? Well, that's pretty straightforward, right? So on Friday, black pen. On Friday, she did 5 texts, 3 people. That's 15. On Saturday, 7 times 6. Ooh, is that 42? I think that's 42. 42. So how many more did she send? Or how many more did she send on Saturday? And you do 42 minus 15. So up to 2, the 3, 2, 12, 7. So 27 more. 27 more. And that'll bring you guys to your quiz. And there's your quiz, order of operation quiz. And now we're coming to our last assignment. This is the Daniel Boone. Many of you guys may have even heard of Daniel Boone. It's kind of his fancy hat that he wears. Old Daniel Boone. Daniel Boone. I think there's even a county in Kentucky named Boone County, B-O-O-N-E, named after Mr. Daniel Boone. So let's go to that assignment. Whoa. Sometimes when I scroll down, it like jumps really far ahead, and it really confuses me. So we are in module number 6 now. Daniel Boone moving west. Yes, they're trying to move west. There's a lot of land west, so everyone's trying to move west. So, westward movement. The frontier or the unexplored area of the United States present settlers with an opportunity for movement into the west. This expansion is called westward movement. It was very important for the early American culture. The settlers viewed the movement west as an unlimited opportunity. The west they may find land and riches for a new life. So you've probably heard of Daniel Boone. He was one of the men who was most famous for exploring the frontier. We'll watch a little bit of this video to find a little bit more about Daniel Boone. Obviously, you guys can watch more of this video on your own.
Necessity.
Too far, sorry.
I remember when my grandfather took me to this fishing spot.
Your grandfather?
Yep.
I didn't know there were people here that long ago.
Oh, heaven, yes.
This kid's got
Fact
jokes.
is, one of them was the famous pioneer, Daniel Boone. He lived not too far upriver from here, more than 250 years ago.
Wow, that's a long time ago.
Sure is. Daniel's father, Squire, worked for himself as a weaver in Gwynedd, a small town north of Philadelphia, to support his wife Sarah and their 11 children.
Whoa.
Daniel, the sixth of Squire and Sarah's kids, spent his summers tending the family's livestock. Even so, he had a lot of time to roam in the nearby woods, which was his favorite thing to do.
That's cool.
Daniel even made friends with the Native Americans who lived near Gwynedd. When he was 12, Daniel got his first gun, a big event in those days. Unlike today, rifles were a necessity, and when a youngin got his first gun, it showed that he was becoming a trusted adult. Guns were needed for hunting, one of the main ways people got food in those days. Within a few years, Daniel was known as an excellent hunter and marksman. Now, about that time, in 1750, Daniel's parents had a serious disagreement with the members of their church. So the Boones left the Quaker church and moved south to settle along the Yadkin River in the English colony of North Carolina. Now, when they moved, Squire Boone quit the weaving trade and became a hunter like Daniel. They hunted for the next 5 years. Then, when the French and Indian War broke out in 1755, Daniel, now 21, joined the British Army as a wagon driver. George Washington was an officer in that same regiment.
I wanted to point out right there, yes, George Washington was a part of the British Army at one point.
Daniel and the other soldiers in their unit were on their way one day to attack Fort Duquesne, a French garrison where Pittsburgh, Pennsylvania stands today.
And I want to stop it right there to get you guys to watch that video on your own. What happened next there? This is a good video. You should really take some time and watch the rest of that video. Excuse me. So, to the west. Even before the American Revolution, many people had traveled into the wilderness of the Appalachian Mountains. So they're starting to get into more our area where we are, where we live. They ventured even west through the areas that unknown might be dangerous. These explorers were hunters and trappers, and Daniel Boone was one of them. He created many new trails that would travel along after he was gone. One trail he went through was Appalachians called the Cumberland Gap. Cumberland Gap. It was also a good place to get across the mountains. So good that people brought his whole family across with him into Kentucky. This trail became known as the Wilderness Road. Maybe some of you guys have been there before. Maybe vacationed there. This painting shows Daniel Boone leading settlers through the Cumberland Gap in the Appalachian Mountains. I think I went there as a kid several times. Old Kentucky home. When Daniel Boone arrived in Kentucky, it was this wilderness. Here is how he described in his 1760s. One day I undertook a tour through the country. I climbed to the top of the commanding ridge, looked around in delight, and I saw the ample plains with beautiful lands below. At a vast distance I saw mountains lift their heads and reach the clouds. All things were still. I lit a fire near a fountain of sweet water and feasted on a buck, which I had killed a few hours earlier. I continued this tour and explored days considerable each part of the country. Each day I was pleased with the first. Soon after I returned to my home and family, I determined it was time to bring them as soon as possible. Live in Kentucky! I thought it was just a second paradise. Rules for the West. What rules? Rules? When the Americans won the independence from the British, they also acquired land south of Canada and east of the Mississippi River, as my grandma called it. I call it the Mississippi River. There need to be rules for all kinds of this land. The Northwest Ordinance of 1787, officially titled the Ordinance for the Government of the Territory of the United States Northwest of the River Ohio. Hey, we made it. Established the rules from a new starting point to new territory governments and applied for statehood. The Northwest Ordinance established a government for the Northwest Territory and provided a method for accepting new states and a territory into the Union. It also listed a Bill of Rights guaranteed to the territory. Using ideas stated by Thomas Jefferson, the Ordinance of 1784, the Northwest Ordinance detailed a plan that the government continued to use as the United States expanded towards Pacific Ocean. Here's a short little video of them traveling to the West.
In 1783, when the United States and Great Britain signed the Treaty of Paris, officially ending the War of Independence, these were the boundaries of the new nation: the Atlantic Ocean on the east, the Mississippi River on the west, Canada on the north, and Spanish Florida on the south. As we can see, that included much more than just the original 13 colonies. It included territory known as the Western Lands. Great Britain had won this land from France at the end of the French and Indian War. In 1763, when the war ended, France lost all of its territory in North America. Great Britain acquired French Canada, as well as the rich lands of the Ohio River Valley. American colonists moved right in. Native Americans living on the land attacked the settlers, and the British sent in troops to protect them. This was very costly. So, the British issued the Proclamation of 1763, stating that there could be no settlements west of the Appalachian Mountains. The colonists were furious. Things got worse when the British imposed new taxes on the colonists to pay for the soldiers.
So, this is why some people think one of the reasons why, if I can go back, the Declaration of Independence, the war with Great Britain was part and parcel because of Ohio. People wanted to get right here, right? They weren't allowed going past this barrier right here. Although this land was owned, they weren't allowed going over here. And right here was really great land, which is known as Ohio. So some people think that some of the reasons why the Revolutionary War was fought was because of Ohio. Kind of cool, huh?
Colonists to pay for the soldiers that they had to send to the Western lands. All of this led directly to the Declaration of Independence. So, when America won the Revolution, it also won all of the British lands south of Canada and east of the Mississippi. The new United States now had to decide what to do with this land. At first, the states were given control, but that didn't work, so a new plan was developed. The plan was called the Northwest Ordinance of 1787. Under the Northwest Ordinance, once the population of an area totaled 5,000 free males who owned at least 50 acres of land, the people could elect an assembly and establish their own government. When the territory had 60,000 people, it could apply to become a new state. From all this territory came the states of Ohio, Indiana, Illinois, Michigan, and Wisconsin. A part of Minnesota was also in the territory. Kentucky was originally a western county of Virginia. It became a separate state in 1792. In 1796,
So, this takes you guys, or us, all of us, to our final page. That's cool. I got a little side view shot of myself there in our final page. So, just to recap our lesson for today, let's go back. That lesson kind of hidden down there. We did a reading and we did our short video, What Makes You Happy? And then we did our sentence editing quiz, 2 questions there. Our conservation of mass quiz. This is a little bit of a longer one. And then our order of operations. Remember our friend PEMDAS. Please excuse my dear Aunt Sarah. Remember, we do multiplication, then division first, and then addition, subtraction. Multiply, divide first, and then addition and subtraction, and then our Daniel Boone quiz. Don't forget that little video there that I stopped a little partway through. What happened to Daniel Boone? So, with that being said, I want to wrap up class, and I will see you guys bright and early Tuesday. Would it be Tuesday morning? Yeah, it would be Tuesday morning because we do not have school Monday morning. So I'll see you guys Tuesday morning next week. So enjoy your long weekends.